Hello guys, welcome back to my channel. So in continuation to our previous video on how to fetch the OI data from NSE website. So in this particular video, we'll talk about the processing of the OI data. Since if you look at the option chain, since it's a huge lot of data, so we'll see how to process it and fetch whatever is important to us. And then we'll also use some libraries to visualize the OI data, and then we'll also calculate the put call ratio. So let me just go back to my Python terminal. So assuming that you have already created the data frames for both calls and puts. So here I've just created two data frames for both calls and puts. If not, you can just check out the previous video. So I'm just gonna print the call data frame, and here it returns the call OI data with different strike prices going from 41,000 to 54,500. So as you can see, this is a huge data with different information. Like it has the open interest, and then it also has the total buy quantity, sell quantity, and it also has the last price for that particular strike. And here it also has another column for the underlying value. So the underlying value is basically the last traded price of that particular index or stock that we are looking at. Now since this is Bank Nifty, so the underlying value or the last traded price was 48,159. And as you can see, this is the same for all the strikes because it's the same index that we are talking about, right? So I'm just going to use the same to get the underlying value, and then we are just going to decide the ATM strike prices so that it would be helpful for us to decide the in the money and the out of the money strike prices. So let's proceed further. So here, as you can see, to get the current value, I'm just parsing the column, the underlying value to it, or the key to my data frame, and then I'm just taking only the first element. Since all of the elements are anyway the same, so I'm just taking only the first index of it. So my current value is 48,159. Now since we already have the current value of the index, so I'm just gonna round it off to the nearest 100 multiple so that I could get the ATM strike value of it. So here I'm just using this round function, and then I'm just rounding it off to the nearest 100 multiple. So as you can see, my ATM strike is now 48,200. So now since we already got the ATM strike, I'm just gonna parse it or compare it to my call data frame of strike price column so that I could get in what index it is sitting in. So what I'm going to do is, since my ATM strike value is 48,200, so in this CA data frame strike price, I'm just going to compare each and every element with 48,200, and then I'm going to get the index of it so that I have the index where the ATM value is sitting. So in this video, we'll try to fetch the first 10 or the next 10 strike prices after the ATM or before the ATM. So I'm interested only in the 10 strikes of in the money and 10 strikes of out the money. So to do that, first I need to get the ATM index, right? So that's what I'm just trying to do over here. So here I'm just trying to compare it. So C of strike price equal to ATM strike. So what this returns is an array wherein it will compare the strike price of each column with the ATM strike, and it will just return 1 or 0, 1 or 0. And then I'm just going to use dot index. And to do that, as you can see, the index ATM is outputted, and the type of it is a pandas index. So this particular pandas index, it also has an another function to get the value of it. I could also print it. So index ATM. So index ATM is basically an index object of the pandas module. So and to fetch the value, numerical value of it, so there is an another function to it. So which is basically the dot item. So I'm just gonna take it index ATM dot item. So now my ATM index is 46. So that's how I'm getting the ATM index value. And now we could just play around with the number of strikes that you are interested in. It could be 10, 15, 20 below or above the ATM strike price. But my ATM strike is at 46. So later in this video, we'll see how to focus only on the first 10 strikes from the ATM, or be it in the money or out of the money. So here you could also do an comparison with the strike prices as well. but I prefer to do it through indexes because if we go by the ATM strikes, not all ATM strikes OI data would be available, right? Because of liquidity or be it any other reason. So that's why I'm willing to go by the index value itself. But if you are interested, you could also do that. So you could use the .loc function in the pandas, and then you could just you could just parse your condition that you are interested in, like strike price greater than ATM strike minus 1000 or less than ATM plus 1000. So basically this will return the all the elements wherein ATM strike minus 1000 to ATM strike and ATM strike to plus 1000. So this is how it could be, but I would prefer to do it through the index. So I'm just taking only the 10 strikes of the calls and the puts. So 10 strikes underscore C is equal to, I'm again using the dot ILOC function. So dot ILOC is basically the indexing method in pandas through integers. So since my ATM index is an integer, right? So I'm just using the dot ILOC method. So ATM index minus 10 is to ATM index plus 11. So here, as you can see, I'm using 11 because it would basically not consider the last index. Let's say the last index was ATM index plus 10, it would not consider the last index at all. So that's why I'm just adding and one extra to it so that I could get even the last element of the ATM index plus 10. So that's how I'm interested only in the 10 strikes of in the money and out of the money. So I'm just gonna run it, and then I could also print it. So 10 strikes underscore C. So here, as you can see, my 46 was the ATM, right? So my 46 ATM, and then I'm interested only in the 10 strikes. So I have data from 36 to 46 and then until 56. So I have the ATM, and then above 10 strikes and the below 10 strikes, I have all the data. So if you are interested in any other strike prices, you could also just play around with this value, but just make sure to add one extra at the end because it will not consider the last value. So that's how I got the 10 strikes of both calls and the puts. And later, if you are interested only in few particular columns, so you could again use the LOC method. So LOC is method is another pandas method for indexing. So here you could feed your rows and columns. So since I want all the rows and I'm interested only in this particular columns, like it could be any other column that you are interested in. I'm currently looking at strike price, open interest, change in open interest, last price, buy quantity, and the sell quantity. So I'm just gonna run it. So here, as you can see, now I have only the data that I am interested in and with all the 10 strikes of data. So that's how you could just play around with it. So you could be interested in any other columns from the entire data from whatever you have created. So you could just feed them over here. So this is just a column because I'm interested in all the rows. So that's why this is rows, comma, columns, and or it could just be strike prices and open interest itself. So I could just delete it and then I'll just re-execute it. So here, as you can see, it returns only the columns with the labels as strike price and open interest. So now, so we have discussed about how to process this information and to get the information that you are interested in. So later we'll also see how to visualize this particular data at different strike prices. And to do that, I'm using the matplotlib library in Python. So I'm just importing it, and then there are also some processing to be done by using some mathematical equations. So I'm just importing NumPy, and then I'm just importing the matplotlib as PLT. So I'm just gonna first create a figure of it. So PLT dot figure, and it will just create a figure. And in the same figure, I'm just gonna plot the open interest data in the form of a bar graphs. So bar width I've just set it to 0.25, and here I'm just setting the x-axis as well. So x-axis I'm just printing the OI data in a bar graph at each strike price, right? So that's why I'm taking my x-axis as the strike price. So here I'm just printing two bar graphs. So one is for the call option and the other one is for the put option. So that's how I'm gonna print it. So here plt dot bar. So this is the one for the calls, and this is the one for the puts. And here, as you can see, I've already color coded them for maroon and green as well. You can just play around with it. So this is just for visualization. So I'm just gonna run it. Oh, something is wrong. Oh yeah, 10 strikes underscore C or P. Anyway, it's the same strike price for both calls and puts. So here, as you can see, so here you could see the information in a very pictorial method or in a bar graph wherein you have the OI data for each strike prices. So as we have already discussed, the maroon is for calls and the green is for the puts. So you could just play around with it and then you could just visualize this data. So you could just get this data for every 5 minutes from the NSE website, and then you can just print the OI data in this pictorial format. So this is just another way of visualizing it. So there are actually a lot of things that you could do with matplotlib. So there is also another function wherein you could get the data by hovering your cursor onto that particular bar graph. So even that is also possible. If you are interested, you could just look at the matplotlib library on the GitHub. So as you can see, this contains all the information of all the 10 strikes. So my 48,200 was the ATM strike rate. And here I have 10 strikes out of the money and 10 strikes in the money. And here I have the data for both calls and the puts. So this is just another way of visualizing your data instead of just reading the numbers. And later we'll also see how to calculate the put call ratio as well. And to do that, so let's again see how the data is structured in the NSE JSON object. So here, as I mentioned, I'm already using the existing PyJSON viewer. So I just run it, and here, as you can see, you have records and the filtered. And in the filtered column, you have for both calls and puts, as you can see, you have the OI data and the volume data. So this is basically the total OI and the total volume for all the strikes in that particular expiry. So that's how you could fetch the data of the total OI and the total volume. So we are just going to use the same to calculate our put call ratio. So so here I have already written it. So volume and OI. So I'm just gonna get it from the filtered key for both CE and PE. And as you can see, the volume OI CE, it contains both OI and the volume. So I'm just gonna print it, volume underscore OI underscore CE. So as you can see, it contains both total OA and the total volume. And I'm just taking respectively the OA and the volume data for both calls and puts. And to calculate the PCR ratio, I'm just taking the open interest of the puts divided by the open interest of the calls. So that's how I'm getting the put call ratio. So that is all from my side for this particular video. Thank you.